Welcome to the second half of Chapter 3 notes. I need you to make sure you have a calculator out. We're going to find the intercepts and the vertex with calculators this time. So go to y equals and type in the equation. We're just going to use a standard window, -10 to 10, and then graph. So this parabola is going to open up. We can tell that because the leading coefficient of 1/2 is positive. That also means that the parabola has a minimum value, and we'll start by finding that minimum, which is also going to be which we'll do by finding the vertex. So to find the vertex, you need to do second calc minimum number 3. Then use the left arrow key and move to the left side of the vertex. Press enter. Use the right arrow key, move to the right side of the vertex, press enter, and then enter one more time. And so the vertex is -2, -3, which means the minimum value is -3. It also means that the axis of symmetry is x equals -2. Next, let's find the zeros, or the x-intercepts. To do that, you'll do second calc 0. Use the left arrow key, move to the left side of the 0, press enter, move to the right side of the 0, press enter, and then press enter one more time. So the first x-intercept is -4.45. Now let's find the other one. Second calc 0. Move the arrow key so that you're on the left side of the 0 that you're looking for. Press enter. Move to the right side, press enter, and then enter one more time. And the other x-intercept is +0.450. Looks like I graphed my vertex in the wrong place. Let's fix that. -2, -3 is over here. That's better. Okay, so we have the x-intercepts. Now let's find the y-intercept. In order to find the y-intercept, you will press second calc value and let x equal 0. The y-intercept is 0. Oh, I think I moved my graph. I think that's why my there, that's better. That might have been what happened last time. Okay, so we have our axis of symmetry, the minimum, the vertex, the intercepts. I think that's everything we need. So now we can go ahead and sketch the graph of this parabola. If you use your calculator on the test, just make sure you sketch the graph that you see on your calculator and label all of the critical points. I would like for you to pause the video now and try number 5 on your own. Once you've done it, restart the video to check and see if you've done it right. Okay, once you've graphed it, your vertex should be -4, -5. Your graph opens up. The minimum is -5. the axis is x equals -4. Your x-intercepts are -6.240 and -1.760. The y-intercept is 0, 11. And that should be enough information to sketch your graph. Next, we're going to come up with an equation given the vertex and a point on the line, on the parabola. You're going to use your parent function, y equals a times x minus h quantity squared plus k. The vertex is the h and the k. The point is the 2 and the 3. That's your xy. Make those substitutions to find the a. So for this problem, a ends up to be 1, so there isn't a stretch factor. And then we go back to the original parent function, put in the 1 for the a, replace h with 4, and replace k with -1. And so the equation for your parabola is x minus 4 squared minus 1. You don't need to multiply that out, just leave it in vertex form just the way it is. This is another one just like it. So start out writing your parent function. Replace the y with 0. Substitute -1 for x. H is -2. And k is -2. So we end up with 1 squared times a minus 2. So the stretch factor is 2. And the equation is y equals 2 times x plus 2 quantity squared minus 2. We're moving on now to application problems. Find the number of units that produce a maximum revenue. Notice that in this function, the x squared has a coefficient of -0.1. This means that this parabola is going to open down because the coefficient of the x squared is negative. It's going to have a maximum value. R is the total revenue and X is the number of units sold. The question says, what is the number of units at the maximum? So this is X, R, which means we're going to want the X coordinate of the vertex. The X coordinate of the vertex, if you remember from part 1 of the notes, is -b over 2a. -b over 2a for this problem is going to be -900 divided by -0.1 times 2. So that's going to be 900 over 0.2, and so x is 4,500. Now you can also do this on your calculator by graphing. If you'll look over here, I've graphed the parabola and found the maximum. The challenge is usually to find the window. The window ended up to be from 0 to 10,000 and from 0 to 3 million. So a lot of times it's easier just to go ahead and use the -b over 2a. Now if we needed the actual revenue, we could substitute the 4,500 in for x and calculate that, and that will give us the total revenue. Let's try one more. Actually, I think we have two more. This one is a maximum profit. Again, if you look at the x squared, you'll see that the coefficient is negative 0.5. So again, we have a parabola that's opening down, and the maximum is the vertex. P is the profit, and X is the amount a company spends on advertising. The question says, what expenditure for advertising gives the maximum profit? So just like the last problem, we're going to use negative b over 2a to find the x-coordinate of the vertex. This time, b is 20. It's always the coefficient of the x. And a is negative 0.5. So negative 20 over negative 1 means that x is equal to 20. Now be careful because it's actually 20 in hundreds of dollars. So $2,000 is the amount that the company spends on advertising. For our last problem, you need to draw a rectangular pen. We're going to separate it into two corrals, and we want the dimensions in order to maximize the area. So let's call the lengths x and the widths y. And since there are 200 feet of fencing, 200 is going to equal 4x plus 3y. And then the area is going to be 2x times y, length times width. Now, take the fencing equation and solve it for y. And then substitute into the area equation. So we're going to put all of this in for x, in for y right there. So our formula is a equals 2x times 200 minus 4x over 3. Now, if you graph that on your calculator, you're going to get a parabola. And the vertex of that parabola is 25, 1666.6 repeating. You'll need to be careful, the window is a bit of a challenge here. The window that I used for the x was 0 to 75, and for the y it was 0 to 2000. Now, this maximum is telling you that the x value that gives you the largest area is 25, and the 1666 is the maximum area. So the dimensions of the pen, x is 25, and then we still need to find the y. So 200 equals 4 times 25 plus 3y, and then just solve that. And so the dimensions of the pen, since we have 25 here and 25 here, the actual dimensions are 50 by 33 1/3. This concludes our notes for today. Please put a question mark next to anything that you have a question about, and we will talk about it in class tomorrow. Don't forget to bring your books. See you tomorrow.